Thanks for being here. As he said, we're going to talk about a little bit of laptop DevOps and local environment and why we think it's important to have a healthy one. We're going to talk about local environment, what we understand by a local environment, why we think it's important. We're going to provide some tools and techniques to get a healthy local environment, and we're going to talk about how this all fit in the modern practices of continuous delivery and such.
Because as we've been working on our projects for our clients and our own projects to other companies before we joined ThoughtWorks, we keep running into this idea of developer productivity. And it's really important on all of our projects to have some reasonable level of developer productivity. And we found that's very closely related to my ability to get things done in a local environment before I get into my shared environments, my shared master branches, things like that.
We've seen that there's a common approach to having environments, which is having a shared test environment. Yes, sorry.
Let's think about a little bit, why do we have this shared and test environment? I have my code locally. Maybe I don't have my code locally. Maybe I'm using a large monolith where I can't even run it locally. So I'm making some code changes, committing, and hoping for the best. I don't even find out if it works until I'm in my slot environment where we can run a few of these monoliths for the developers to play around with. Maybe I'm writing code for a BPM extension, and I can't run it because of licensing problems or because of software on my own computer. So that might be one reason. Or I have my local repository where I'm making changes, but I have lots of dependencies on other things that I don't have enough copies to test with, so I'm running those in my shared environment.
Another problem that we've seen is that since too many people are touching their environment or working there, and something's breaking, it's very difficult to know what was the change that broke the environment.
And these types of shared environments especially aggregate these types of changes that are subtle because nobody really has dedicated responsibility. The only times we do see where somebody has responsibility is when it's given to some type of ops support team. And their solution to this is nobody else is allowed to touch anything without at least a few emails in a meeting. And this obviously slows down my pace of development.
Then what if this is not the best solution, what other options do we have? OK, we can just do it live. We can hit the real external dependencies, the real staging, the real production environment of our dependencies. This could make sense in some cases, but you have to be careful that you have to, for example, if you're sending some data, that data is treated specially because if you're testing like an ordering service, you don't want that order to become to get to the real destination, right? The good thing is that if you're hitting the production environment of your dependencies, you know for sure that it's going to work in production. You have to keep in mind that it has some drawbacks as well.
Yeah. In the theme of lean software delivery and continuous delivery, we wanted to bring this up as something that we're not going to go into too much depth with. But if I have a dependency on a read-only service, in certain cases we have seen clients and other organizations that we have a lot of respect for their engineering practices use this successfully in certain situations. Why is local development going to solve any of these problems? Why does it make things any better? But to do that, we'd start with defining what is local development. So, yay, it's the ability to develop my software without external dependencies. But what do I really mean by that? An easy one. If it's not on my computer, I shouldn't need it. So here's a good way to test that. How about turn off my internet connection? Can I do anything useful on my team right now? I don't want to be dependent on software outside of my laptop. So this immediately is going to cause a lot of problems for cases we were talking about before. I have a monolith that I can't run on my own laptop. I have to have this specialized dev slot where it runs. I'm doing some sort of customization of vendor software. Those are not going to fall into this definition. I don't want to share dependencies with other developers. And this is where I start getting into things like databases, where it's not that helpful if I have a very data-driven application. And while I may have my own copy of the application code, I don't have my own copy of data. Ideally, this is going to give me some sort of benefits. So yay, I don't need the internet. That has a little bit of an advantage. I can work on the plane. But more importantly than that, It gives me the ability that I'm not dependent on how good my internet connection is for how successful my team is. I have my independent sandboxed environment. That's great. But getting more interesting, I have the ability to make certain changes which I couldn't before and see if those work. Debugging is a big thing. I don't know if you've ever tried to debug something on a shared environment where other people are also using it. But if I have to deploy to this shared environment to have a realistic picture of my application running, setting breakpoints there becomes a cause for fighting amongst my team, because now everyone's wondering why their calls to this service hang. What we're really talking about is testing of our application, that I can be sure that it actually works locally before I commit, before I push to a shared environment where I affect other members of my team or other teams. And when we talk about testing locally, what do I want to test locally? Because we already talked about, if I'm following good practices, I have unit tests. So I'm already testing core components in my logic locally. That's not a problem. But especially in a microservices environment where I'm interacting potentially with lots of other services, I want to make sure, for example, that I'm calling these external services correctly, either to orchestrate them, because maybe I'm a top-level microservice orchestrating a few pieces of getting or setting data in response to a user command, or I am have a contract with these other services, and I want to make sure that I'm abiding by that. If other people are calling me, I'm responding in a way that these other services are expecting. In modern software development, I have tightly covered infrastructure. These might be things like databases. This might be things like a search index, maybe in my messaging middleware if I'm working on an event-driven application. And I really want to make sure that I'm interacting with these correctly. And of course, as Marcus was mentioning earlier, data is key. And I would like to be sure that my application works with some sort of reasonably representative prod-like test data and configuration. Especially as my application gets more complex and more data-driven, different data can result in wildly differing behaviors in my application.
What is the basic of all this? It's basically to shorten the feedback loop. We want to have results of whether the software that we are building actually works. But you may ask, OK, but I have my unit test. I have my integration test that if I'm working with Spring, I can bootstrap my application and run some end-to-end test in my service. Do I still need to bother with all these problems of having this local environment where I can start my services? Well, yes, because you still want to check that you're correctly connecting to the infrastructure and to other dependencies in your machine. And even with all the automated tests, there's always still room for some manual testing, either because you want to do some exploratory testing, or you want to reproduce a bug that you're not sure what are the steps to do it. And you're always going to find a scenario where you want to bootstrap your service.
So the idea of doing as much as possible locally is not a new one by any means. But there often end up being reasons why we don't end up doing that. Ideally, I'm not doing this for everything in my entire organization. When I have a large organization, that doesn't scale particularly well. So I need to start thinking about boundaries. But to start with, let's take a few services that I constantly need to either test the same dependency with, or they're interacting with each other in a way that is a little bit more coupled than I would like. The first problem we run into is setting up my own organization services. So I have my dev team. We're all working on the same service. I would like the time where a new developer rotates into my team, because we do good knowledge sharing at my company. Or I have new developers onboarding, and I would like them to be up and running as quickly as possible. So this starts off with, here's some scripts, here's the README, follow this guideline. I would like that to be as short as possible. So my problems here are going to be around, I have different developers with different laptop environments. I would prefer not to, if I don't have to, dictate exactly what operating system every developer on my team is running. Maybe that's not possible for some reason because there are other organizations within my company that have different rules. I would like to have a consistent way of everything being set up, and I would like to not have conflicts between these different services if they have different dependencies on libraries, packages. Maybe OS calls work slightly differently because they're designed to run on different operating systems. I'm sure all of us are using VMs everywhere, and possibly in our higher level production environments. Something like Vagrant will give me at least a little bit of tools to configure that, what is my base image, and set that up in a consistent way. I'm installing these packages. I know this works on my machine. it will work on your machine because we're using the same virtual machine. That's an easy place to start. And we're going to use Docker in our examples here, but you definitely have other options for containerization. And with a good set of scripts and confirming that these pieces run together, you can do the same things with a good VM setup. You're just going to need a little bit more in terms of scripting and infrastructure to make sure everything plays nicely together. So just an example here, I'm creating a new product browsing service. So I have the UI, and I have a couple dependencies. I would like to have some sort of product shown on this. So I'm going to have my product service that I'm going to make calls to. I would like to see how much inventory there is because I want to show that. So I'm going to have my inventory service. And because I want to test certain weird scenarios and how my product and my inventory interact with each other in my service, I'm going to call them directly in this case to do some checking out that everybody's playing nicely the way they should. And if I'm doing a more complicated refactoring, I don't know if you've gone down microservices and realized we have the wrong contract set up. Sometimes it might be nice to build both of these at the same time. So now I keep this advantage of they play nicely together on the same environment, but I can actually make code changes experimentally across both repos and make sure those work together. And that's especially where having this infrastructure can be helpful. I'm also going to have dependencies on my infrastructure, and especially as the software industry matures over time, I have more and more open source software, so it's nice to make use of all these great components. Unfortunately, we often forget about the fact that those should be governed under version control, under migrations as well, and if I'm more coupled to these things, I want to actually be able to test with them. If you can find good images of dependencies that you know you're using in production, like Kafka, like your database, like a search index. Ideally, there is still some configuration around this, and you're making sure that it actually is set up correctly, because you have the problem that generic software is going to be inherently built to be customized a little bit more. You'll see that in your own applications as they get more complicated. So for that, we're going to introduce the idea of infrastructure configuration and orchestration frameworks. So even better in this case, if I can start working with these ops teams. Maybe we don't have good infrastructure automation in production and higher level shared environments, but I can start by doing this in a local way. I like this example here of Apache because it's a great example of software like many Apache projects that slowly do everything over a long period of time. So just for the fact that I have Apache as an Apache server as part of my organization's stack is no guarantee exactly what it does. So here we have an Ansible setup of basically installing the packages we care about and doing a bunch of configuration.
You have your service, and generally you connect with other services, especially in a microservice architecture. How do we deal with the fact that I cannot connect to the internet, but I still have some external dependencies? Well, one option is to use contract testing. So whenever you make a change, and this test will be executed, and if something breaks, that means that you're no longer complying with the contract. So either you fix what you changed to comply again, or you have to go talk with the team that is managing the other service to figure out how you're going to comply again with it, define the new contract, basically. A good tool for this is Pact, that has support for several languages, and where you can have a broker with all the contracts, and both services use those contracts in that broker. And for example, if I want to test an edge case, you can use something like Montebank, where you can define stubs that are returned over the wire. So you will be defining whenever I make this call, I want it to return this response. It's like stabbing or mocking in your unit test, but over the wire. And in that case, in this scenario, we'll be making sure that you are, for example, serializing and deserializing correctly the responses and requests.
Just as an example here of where might this be useful, if I have good testing, I'm hopefully checking that I'm receiving things the way I should. I don't want to test my libraries too much. But let's say in production, my application is throwing a weird error when I'm getting an unexpected response from another application. So I go in my logs, I find out what the other application responds with, and now I can plug that in here using my dev workstation to spin up the Mountebank infrastructure. But now I can replay this response. Maybe it's something even a little more subtle in terms of HTTP and not just the JSON payload itself. It takes a long time, returning maybe the wrong status code but the right data, and I can now use that to set up and play around in my local environment what exactly happened here.
We also mentioned that data in the shared environments can get very bad. So how do we deal with this? An option is to version your schema changes. So instead of making a script and executing directly on the database, you define the script, but you version it and you rely on a tool like Flyway to execute this test and to make sure each script is executed only once. In this way, for every feature, you will be making sure that whatever data you will need for that feature are there. And this could also start some interesting conversation with the business people to figure out what is the data that you actually need.
So this is a pretty trivial example with just creating a couple people. But this practice gets really, really useful when a given service has in their repository, here's a reasonable set of data that will exercise the basic logic flows of our service. So that now when I'm interacting with that service, I maybe don't know everything about the internals with that service, but if I maybe try around with the different products, they're going to activate different logic in that service and respond with interesting data. I can now use that and see how my service interacts with that. One fun topic that I always like to bring up on the idea of local development is that of networking. And this is unfortunately because it's one of those things that is, by nature, pretty different between your local development environment and higher level development environments. One is that our local environments are often running things like Docker containers we're talking about. They're not really the same. Of course, we talked about before simple things, like I have conflicting ports and I need to sort that networking out if I want to run these services together. But we have more complicated things. As I'm testing more and more services together, they may have lots of dependencies in their configuration about who they're talking to. If we're working in a slightly more advanced way, I'm doing some sort of service discovery, and I'm not even sure if I can run that in my local environment. So we're not going to give explicit solutions here because it's very dependent on what is your production and maybe high-level QA environment setup versus what are you running locally. But there's different things to be worried about. I could maybe implement full service discovery locally with whatever way I'm doing that in a higher level environment. I just have questions about how much work is that to do? How different is it going to be from prod? Because if it's very, very different, it kind of defeats the purpose. So is it really worth the investment? Of course, as we're talking about agile software development here, it's fine to hack something together to start with. Ideally, I don't have too many dependencies, so I start with 2 services talking to each other to solve my problem because they have a shared messaging system, spinning this up in my local development environment. So I can just script that together, put a piece in their config file to start with.
What things should I test locally? Should I test everything locally, or are there some things that should be left out for another environment? In general, you want to test locally some end-to-end core of your business logic in your service. You also want to check that you're correctly interacting with your highly coupled dependencies. You want to use it to check a bug reproduction, some exploratory testing, or with this contract testing or stubbing over the wire, some dependencies on some other services. You don't want to test the performance because it's going to be very difficult in your production environment. So it doesn't make much sense. You don't want to test the platform itself. You want to make sure that you're correctly interacting with it, but not the platform itself. And depending on the size of your microservice architecture, you don't want to test every feature end to end.
What have we learned here? Hopefully that local development is a good idea. There are some challenges we have to overcome, but we can overcome them with a bunch of tools we have in our arsenal. But it's really part of a larger picture of my push towards CI/CD, my push towards having a really short response time between when am I making changes and when am I sure they work. So now for example, my services now can be created and deployed programmatically. That's fantastic. This is getting towards sounding like infrastructure as code, like continuous delivery practices, and I have good infrastructure automation. So what we see the local development environment as is supporting of these practices. So if I'm starting in a brownfield situation, it can be a first step that I take in how to get there. I can solve some of these problems locally and promote them up through my environments. And eventually, I can start taking out some of the code from this developer workstation because now I've separated out these infrastructure dependencies and how they're configured into dedicated repos that are maintained by my ops teams. Do I even need CI anymore, though? I'm doing everything locally. Can't I just push to prod? I still want all these CI pipelines for all the reasons that Rebecca tested about, testing some of these things that I can never test on my local platform. But I can be a little bit more liberal with my pipeline. Even though there's more steps, I'm running lots of things locally and testing them locally before I go into my pipeline, my overall speed through my pipeline is going to be faster because it's read way less often. And that means I'm more productive because I don't have to worry as much, can I push my changes through to production? Because me and the other people on my team and the other teams are catching these issues before they get into a shared environment where it slows everybody down and nobody can push changes through until the build's green again. This keeps my build green while I'm still pushing quickly through to production. Thank you.
Thank you.